Hey everyone, this is the third video of our design pattern series, and today we are going to discuss about singleton design pattern. So just like factory design pattern and the builder design pattern which we discussed in our previous video, it is also a creational design pattern, and basically it restricts the initialization of a class object to just one instance, right? So where it can be used whenever you need to create only one object. For example, there is DBManager, there can be file manager, there can be schema manager, and you know that you just need to create only one instance of that particular class, and throughout the execution that instance can be used, right? For example, for a driver manager, when we talk about a test case execution, for example, one test execution only need one driver, then we know that we do not need to create new driver manager again and again. Only one instance will be enough, right? Similarly, for backend, it can be a DB manager and a schema manager. Similarly, there can be, of course, if there are different APIs, you can have a API manager as well, right? Then talking about the implementation part, this is very basic implementation. We are not talking about thread safety as of now, right? So for very basic implementation, what we can do is like we need to create a private static reference variable of a class, right? And then we will create a private constructor. Why private? Because we want to restrict the initialization of any object of this class, so that we do not want other classes can call new class name and then brackets to initialize the object. Then where this reference variable will be initialized, we will create a static method which will be a public method so that other classes can call it. But here we will take care of both getting and setting the instance, and while setting the instance we need to make sure that the current reference variable value is null. Only then return a new object, otherwise return the same object, right? And in our future videos we'll discuss about how we can make this implementation in a thread safety manner, right? But for now this basic implementation is what we are going to start with. Then for demo part, I have again used the db.json from our previous video where we discussed about the factory design pattern. And let me open it. So this is our db.json, and it has a product array with the 4 object, and similarly brand array with the 3 object. Now we are talking about the structure because while implementation, the demo, we will be talking about JSON schema validation, right? And then to start this server, just need to execute this command json server db.json. It will have a localhost server on 3000. Once you will open it, it will look something like this. It will have like resources, product and brand. Here you have the product array from your db.json, and here you have brand array. So whatever the whatever the array you can want to create in this localhost, you just need to put those array within your like db.json, and those will appear as a resources here, and you can open them. For our demo of schema manager, like we will be creating a singleton implementation of schema manager. These two are enough for now. So let us move to IntelliJ now. So as part of this singleton implementation in rest assured, we will be talking about JSON schema validation. Now let us quickly see how we do it normally. Like what we have is like, for example, we know that this is my response for get products and this is my response for get brands. So I will pick these and go to any online tool which convert a JSON to a JSON schema, right, and put it there. For example, I have already placed my response of get products here, and then it is a JSON schema that is getting created. We know it starts with an array, so here we can see array, and then each array will have, here we have 4 objects, right, and here it is. So it doesn't matter how many objects you have, the JSON schema which is getting created, it will pass even if you have 3 object, 5 object, 1 object. The only thing it considers is the structure of your JSON, right, the schema. For example, array, then 4 objects. So here it is saying you have an array, then you have an object, and then each object consists of id, which is a number, then name, which is a string, similarly description is a string, and then price is a number. And in the end here it says that what are the required fields for each of your object. So for example, if you know that some like this description, it is not a mandatory value, it is not a mandatory key, just remove it from here, right? So what I have done is I have taken these two schemas which are getting created here, placed it here in the created a schema folder in the resources, put it here, right? And if I show you the previous implementations and the difference, just to show you what the changes that I have made from our previous implementation of factory design pattern. So this is our, like, let me quickly show you. Yeah, so previously we were hard coding the endpoint names which we want to use in our test. Now I have just created a static inner class here which will hold all of these endpoints name in form of a string variable, and instead of calling these hard coded value within our test, or in this example we see in schema manager as well, we will be using these names endpoints dot brands, endpoints dot brand. So brand means a brand here and brands mean brands here. So we have made that mapping, and the same mapping I have made in our product service class as well, right? Then here within the resources I have kept two schemas, made a change in build.gradle to have a dependency of JSON schema validator, created a file util to read the schema files, and it will return the file content in form of a string, right? And this is testng.xml, created a new test class for this implementation and pointed the testng.xml to that class, and then in the end this is our test class. So now before going into the detail of this, let me show you a very basic implementation of JSON schema validator, like how we normally do it. So this is same thing what we have done previously. We are just creating the instance of our service. So here we have implemented factory design pattern, right? If you remember from our previous videos, it is a service interface that we have created which has a default method of get base URL and then build endpoint. So this build endpoint is being implemented by our service classes like product service and brand service. For example, let me quickly show you this. So build endpoint, it will return the endpoint, this thing, the path of the endpoint URL on basis of whether it is whether we are calling brands or whether we are calling a single brand, right? So that we have done in our test class here, and then here we are, like once we get the instance, we are building our endpoint, right? We are just calling it to build the endpoint, and once we get the endpoint URL, we are sending the get call here, and base URL, we know that it is going to be same for every class, so we have put it in our service interface as a default method, and we are calling it here, right? And we have initialized this request specification in static block here. And then for the JSON schema validation, what we are doing, once we have the response here, then we are just asserting the body whether JSON schema validator matches the JSON schema that we have provided here. Like the response that we are getting, it is matching the JSON schema that we have provided on this path, right? With help of matches JSON schema. And let me execute it first. And we'll show you why we are going for the another implementation. First, the basic case where everything will pass because there is no mismatch, right? Now what I'll do, for example, say in the response, in your response you have more than two mismatches. To replicate that thing, I will go to my get products and here I will do two mismatches. One at this ID1 levels. For example, our response is not sending the key name which is expected for the object, right? And then type I'm going to change to the number. I'm expecting like description to be a number. Now when I execute my test again, it will not show us the two differences that we have. It will just show the one difference. So that's why we will use the another implementation, because as of now it is not deeply checking. There is a logic of JSON schema validator related to deep checks, and we will discuss about them before implementing. So here you see it is saying that ID1 is required, but it is not saying anything about the mismatch which is happening on the data type level. It is just talking about the missing attribute for all the four objects, right? Missing required property, and nothing about the data mismatch, data type mismatch. So what I'm going to do is now to show you again. So if I go back to my schema and I make it ID again, now it will show the difference. So now it is saying that instance type string does not match any allowed primitive type, allowed integer, number, right? And it is saying that for description it is happening, but in our earlier execution it didn't show us this difference. So that's why we are going to implement this version where like it will show us both the differences in one place only at one time. So if I go here, let me make it id1 again and id1 again. Now talking about the new schema implementation, schema checks implementation. So here we are doing the same thing, getting the service, then calling the endpoint, setting the base URL, getting the responses, and this is the part where we have implemented schema manager, and this is like singleton implementation. So here if I show you, we have one. Let me open the notes. So first thing was to create the private static reference variable of class that we have done here. The second thing was create the private constructor of a class, which we have done here with the help of Lombok. We are saying that we need no argument constructor which will be private. Then the third thing, create a static method to set and get the instance of reference variable, and here make the initialization in this way that create the new instance only when the value of reference variable is null, otherwise return the same instance. So that we have done here. If schema manager, which is here, is equal to null, then create a new instance, otherwise return the same instance, right? And then here within the schema manager we have put two here we have a hash map, a private hash map, where we will be having, because we know like every response will be having different schema, different response schema for it. So it is appropriate to map them as per the endpoint. So that's why we have created a hash map, so that every endpoint we can have a mapping for its respective schema. And now you will know that why we created this, so that we do not need to hardcode this brands, a brand everywhere within our project. Wherever it is needed, we can just call by the help of our service, like whichever service it is, endpoint, which is a static inner class, and then it has attributes brand, the endpoint name of course, right? And similarly for products we have done the same thing, mapping, just a mapping of endpoint with the schema validation file. and then we are here trying to get the schema. We will be getting it on the basis of course endpoint, right? Whatever the endpoint, we want to return the schema on basis of that. As we have put it in the schema folder here within the resources, we are using file utils.read file here, which is the implementation. Like here we can see with the help of class loader, I'm getting an input stream and then just converting that input stream into a string. So here we will get it, and now when I go to my test class again, here we have the schema, here we have the response. Response is in form of response and string is the schema is in form of string. Now the next thing is we like when we will talk about this implementation, we need both of these converted to a JSON node, like our actual and our expected. So for that, I have created a using JSON library. I have created a mapper here, object mapper from the JSON library, and just using a read tree to convert the string or response to a JSON node object. And after it, it will be ready for the comparison. Now let me show you the JSON schema validation implementation here, what we have done. So first, we have a class which is like JSON schema validator setting. Right, in this first we need to have the instance of this particular class, which we can get if I go to the end. JSON schema validator setting, we just need to call this settings method. It will return the JSON schema validator settings to us, right? And then what we will do with this instance, we will call this JSON factory, like this JSON schema factory here, which is right here, JSON schema factory. So first we are getting the instance of our JSON schema validator settings and then JSON schema factory. And why we are doing that, let me show you. Once we go to the JSON schema factory, here we have a validator. It will return us a validator. Let me go back to the code again. Get validator, yeah. Right, this JSON schema factory basically have different type of validators. If you see here, it has a syntax validator, JSON validator, and JSON schema implementation. So we need a JSON validator because it is required to validate an instance against a schema, right? So this is the thing that we need. So once we get it, JSON schema validator, after it, this validator has a method validate, which will take JSON node as a schema, the response as a schema as a JSON node, response as a JSON node, and then we need to provide a variable whether we want to perform a deep check or no. If we say deep check yes, then it will show us all the differences which are there in our JSON schema at one time. Let me quickly show you here, right? So this is what we have done. JSON schema validator setting, JSON schema get validator validate. Now this validate, what it is returning. This is returning a processing report. So the consolidated report of our assertion we will be able to see here. And it has this boolean method is success. So that means if there is no mismatch, is success will return true. If there is a mismatch, then is success will return as the false. Apart from that, this if you will just print the processing report, right? If you do s out report, you will see all the differences. So what we have done here, like we have used assert j, right? Assertion dot assert that report dot is success. We want it to be true. If it is not true, then we want to see the differences, which we can see with the help of with fail message. And here we have printed our report, which we have get from here, which we got from here, right? And let me quickly execute this again. Now we shall be able to see both the differences at same time because we have enabled the deep check here. So first it is saying required property ID, and then it is saying the difference with the string as well. And if I say I pass it as false, then it will work as our previous implementation. Now it will not show me the difference related to the data type mismatch. But yeah, our main agenda of implementing this is to perform a deep check, so it will always be true whenever you want to implement this part, right? So now it is not talking about the difference in data type, it is just saying that ID1 is missing. And the same thing I have done for the brands as well. We are getting the response, we are getting the schema, then created the instance of a report and then made a session here. And let me correct our schema for now so that we can see it working and passing as well. ID, ID. So yeah, here we can see the comparison has passed. Right, so that's how we created our singleton class here, implemented the schema validation with the deep check, and deep check as true we can make here, right? And let me show you with the execution of deep check as true as well. So let me do it for get brands this time. It will pass because we haven't made any changes. Okay, so that's how we can implement it. So we are done with the agenda for the day, and I will share the source code link to the Git repo in the description section, and as well as notes of this video in the description section. And in case you're liking the content I'm making, please do like, share, and subscribe. See you in the next video. Thank you.